Hello, dear students. Today we are going to start a new chapter, inverse trigonometric function. Inverse trigonometric functions. We'll try to complete this chapter in 2 or 3 lectures. Each lecture will be followed by a worksheet. Today we'll try to restrict ourselves to the basic fundamental concepts only. Now if you see the topic, you have a function here, you have inverse function, and you have trigonometric function, inverse function and trigonometric function, 3 concepts which we have already done in class 11. So before moving to the inverse trigonometric functions, we'll very briefly recapitulate these 3 concepts. First, the functions. Functions. What is a functions? Function is a rule of associations which associate all the elements of set A to a unique element of set B. Set A is called the domain set and set B is called codomain. There is a third set which we call range set. So what is a range set? Range set is a subset of codomain. It is a subset of codomain and is a set of all elements from B which has its pre-image in A. Right? So range set means it's a set of output elements and domain set means a set of input elements. Now by domain we means to find the domain of a functions, we are trying to find those values of x for which the function is well defined, or those values of x which can be taken as input element. Range means the output, the functional output of the input, the given input. Right, let us understand this with the help of an arrow diagram. We have a set A, set B, f is a function from A to B. Let us assume set A has 3 elements, set B has 3 elements. Right? Let us say the functions take A to x, B also to x, and C to y. Right? Then the domain for these functions consists of element A, B and C. Codomain is x, y, z, and the range set consists of the 2 elements x and y. Right? Next, inverse function or invertible function. We know all functions are not invertible, meaning there are many functions whose inverse does not exist. Now when I say there are many functions whose inverse function does not exist, then there must exist a condition or a criteria for the existence of inverse function for a given function. What is the criteria? What is the conditions? Most of you will be able to recall the conditions. The condition is the function f must be 1, 1 and 1, 2. The function f must be 1, 1 and 1, 2. 1, 1 means it is injective. 1, 2 means it is surjective, and 1, 1, 1, 2 meaning it is bijective. Okay? The function is said to be 1, 1 if different elements have got different images. The function is said to be 1, 2 if codomain is equals to range, means for all elements in the second set, the set B, there exists a pre-image for that particular element. Means all elements means the codomain is used up completely. If the codomain is used up completely, meaning for all elements in the codomain there exists a pre-image in A, meaning the function is surjective. Now let us illustrate this also with the help of an arrow diagram. Say this is set A, this is set B. F is a mapping from A to B. Let X be any arbitrary element in set A. Now, the function f will take x to f of x in B. Let us assume this f of x equals to y. Now, let us assume this function f from A to B 1, 1 and on 2. If this is 1, 1 and on 2, then there exists an inverse mapping from B to A, f inverse, which will take this y as the input and will give x as the output. Means this will take y, f inverse will take y to x. F inverse y is the output of y under f inverse, and f inverse y should be equals to x. Correct? Meaning if I write this rigorously, I can write this as for all y belongs to B, there exists exactly one x belong to A such that f inverse of y equals to x. Now, some of you may do the mistake in misinterpreting this f inverse. Some of you may take this f inverse